So the purpose of this video is to review how to write single replacement reactions. So just as a quick review, if you have an element that when it forms an ion is positively charged, if it reacts and it's going to kick something out from a compound that has a positive and a negatively charged ion, a positive will kick out a positive. If you have an atom that is normally negatively charged when it is an ion, then a negative will kick out a negative. So let's see that actually in play. Okay? So number one, aluminum reacts with sulfuric acid. So I'm going to write this out. So aluminum, Al, reacts with sulfuric acid, H2SO4. Okay? So the first question I need to ask is, okay, when aluminum is an ion, is it positively or negatively charged? And the answer is it is positively charged. So what that tells me is that aluminum will kick out another positively charged ion, hydrogen. Okay? So this is the reaction that should occur. Let's quickly look at my activity series to confirm that this reaction does in fact take place. So in order for this reaction to take place, aluminum needs to be higher on the activity series than hydrogen. Okay? Well, aluminum is right here, hydrogen is right here, so this reaction does in fact occur. Okay? So let's write out our product. So aluminum is going to form a new compound with sulfate. In order to write the compound, I've got to cross my charges. So aluminum has a 3+ charge. Sulfate is 2-. Okay, so when I cross my charges, what that gives me is Al2 in parentheses SO4, close my parentheses, and 3. Hydrogen got kicked out, so hydrogen will now be by itself. But remember, since hydrogen is diatomic, it can't actually exist by itself, so it's going to be H2. Now the only thing I need to do now is balance. So I've got 2 aluminums, 1 aluminum, so I'm not balanced there, 1 sulfate, 3 sulfates, I'm not balanced there either, and then my hydrogens are good. So I'm going to start with sulfate. I see I have 3 sulfates here. Doesn't matter where you start, but I'm just going to start with sulfate. 3 sulfates. I'm going to put a 3 in front here. That now gives me 6 hydrogens. So I need to put a 3 in front of H2 here to make 6 hydrogens. And then I've got 2 aluminums on my product side, so I'm going to put a 2 here. And I am balanced. Let's look at the next example. Chlorine reacts with potassium iodine. Okay, so chlorine, remember, cannot actually exist by itself because it is diatomic, so it's going to be Cl2. It reacts with potassium iodide. Potassium has a 1+ charge. Iodide has a 1- charge. So when I cross charges, this gives me Ki. Now remember, chlorine has a negative charge when it forms an ion. Iodine has a negative charge, so chlorine is going to go in and try and kick out iodine. Because positive kicks out positive, negative kicks out negative. Well, chlorine is higher on the activity series than iodine, so that reaction will take place. So now I'm going to have a new compound with potassium and chlorine. Remember, the reason why I'm writing it this way, your positive ion needs to go always before your negative ion. Okay? So when I cross charges, I get KCl. And then iodine got kicked out, so it is going to be by itself. But remember, since iodine is diatomic, it's going to exist as I2. Okay? Now I simply need to balance. I've got 2 chlorines on my reactant side, so I need to put a 2 in front of potassium chloride. I now have 2 potassiums, so I'm going to put a 2 in front of potassium iodide. Now I have 2 iodines on my reactant side, 2 iodines on my product side. I am balanced and good to go. All right, iron 2. So I'm just writing iron 2 to let you know, hey, the charge of iron in this problem will be 2 when it forms an ion. Reacts with silver acetate. Okay, so I've got to write this out. Iron is Fe. It reacts with silver acetate. Okay, well, silver is Ag with a 1+ charge. Acetate is one of my polyatomic ions, C2H3, O2-. Okay, so when I cross charges, that gives me Ag, C2H3O2. And it forms, okay, well, iron, remember, has a positive charge when it forms an ion. So it is going to kick out another positively charged ion if it can. Let's see if it can. It's got to be higher on the activity series. Well, iron is here on the activity series. Silver is all the way down here. So that reaction does in fact take place. So iron will kick out silver. So iron is going to form a new compound with acetate. So it's going to be iron 2+, because that's the charge of the iron, as was noted. Okay. So when I cross charges, I get Fe. Then I'm going to put acetate in parentheses, because I've got 2 of them. Okay. And then silver got kicked out, so it's by itself, and it can, in fact, exist by itself because it is not diatomic. Last thing I need to do is balance. I already know I'm going to have an issue with acetate because I have 2 acetates on my product side, so I need to put a 2 in front of silver acetate. Now I've got 2 silver ions, so I'm going to put a 2 in front of the silver atom here. I've got 1 iron on my product side, 1 on my reactant side, so I am now balanced. Last problem. Iodine reacts with calcium bromide. Iodine, I would love to write by itself, but I can't because it is diatomic, so I'm going to put I2. It reacts with calcium bromide. So Ca2+ reacts with Br1-. So Ca2+ and Br- when I cross my charges, CaBr2. These are my reactants. Iodine forms a negatively charged ion, so it will kick out bromine. Let's check to see if this reaction actually occurs. So iodine needs to be higher on the activity series than bromine, while iodine is actually lower on the activity series. So I know that this reaction will not occur. There will be no reaction.